Hi, Joe Lautner from Tech Home Advisors, your host today for the Tech Home Builder webcast on healthy homes. Today, we're going to focus on indoor air quality monitoring and ventilation. This week, I have with me Brian Rayski of One World Consulting. Brian is an HVAC designer and building scientist, and I have Taz Khalil from Broan-NuTone. And Taz is Associate Product Manager for Home Comfort and Convenience. So we're going to focus on healthy home today, but specifically on indoor air quality and ventilation. Healthy home really has three legs to the stool. It's got water, light, and air. And today with the experts we have, we'll be discussing really about air, keeping the home's air healthy and clean for the occupants. Air is a big issue. I spend time in California. The fires are a real problem out there. And also the American Lung Association recently put together a report about the by region and cities and air issues around them, talking about ozone and short-term and long-term particulate pollution trends. And the issues are throughout the US and Canada. So this is a very, not a regional issue, although some areas have unique challenges. And we'll talk about those today. So Brian, we'll start off with you. Tell us a little bit about yourself and One World, please.
Sure. I'm a mechanical engineer by training. Did a lot of large boiler and chiller plant replacements in my previous career. And, you know, it's kind of the energy codes and the building codes that have kind of brought me here today in terms of healthy homes and high performance homes that are being designed in the marketplace. So our home state is Illinois, but we do work all over the country.
Great. And what's driving the use of your business? Like, who comes to you and says, I need help with my ventilation? What are the key drivers for you getting clients?
Yeah, so our clients tend to be architects, general contractors, HVAC contractors, and the homeowners themselves. They might not know what they want, but they know to ask questions about how to get it. So that's kind of, you know, where we come in. We're a true consulting business. We don't start designing boilerplate systems. We want to understand the client's goals, again, whether it be the architect or the builder, and try and help them meet those goals.
Got it. And so what are some of the problems that you face that your business solves?
So code issues is a big one, right? The codes keep changing every 3 years. A new municipality might be adopting a new code that they previously didn't need to enforce. And now there's a learning curve, right? Whether that be the builders, the installers, or the clients themselves, and how to get these homes built properly.
Got it. And so what types of codes affect how the home needs to ventilate?
Yeah, so One World Consulting was formed in 2010. It was basically because I saw these codes, the International Mechanical Code and the International Energy Conservation Code, being adopted by these municipalities. And so much of what is in residential code now has come from the commercial codes. So requiring a mechanical ventilation system, a whole house mechanical ventilation system, that's 2010 code. That didn't exist previously in residential construction. So that was kind of a aha moment, right? In terms of how the codes were driving how home building is changing.
Got it. Thanks. So Taz, over to you. Tell us a little bit about yourself and what you do with Broan, and a little bit about Broan's ventilation products, but also what's coming down the pike shortly with your new indoor air quality monitoring solution.
Yeah, so like Brian, I'm an engineer by trade, but more on the software side of things. Broan is doing a lot of things when it comes to ventilation. We're kind of trying to become the one-stop shop when it comes to your ventilation needs. So we sell ERVs, HRVs, fresh air systems, makeup air dampers. We also have our kitchen side, which sells a number of different kitchen hoods and power packs, chimneys, inserts. And on our ventilation side too, on our exhaust ventilation, we have our bath fans and a number of other products that we sell there. So we really wanted to become kind of the indoor air quality experts within that area. And then looking in kind of the future and what I do for the company is really bringing in kind of a monitoring piece to that. And we'll talk about that kind of here shortly. But essentially, we're looking kind of in the future as to what we can incorporate when it comes to monitoring your indoor air quality and then actually doing something about it with our existing products today.
Great. Taz, why don't you tell us a little bit about what it is that led Broan to develop a monitoring solution, and what are you monitoring? What's the
Great question. So, we have all of these ventilation products within our homes. We have ERVs, we have range hoods, we have bath fans, but unfortunately, sometimes it's kind of up to the user to decide when to activate them and when to deactivate them, right? And there's never been this kind of feedback loop to identify what pollutants are within your home and for how long you need to ventilate for. It's always been up to a code, like Brian mentioned, that tells you, to ventilate for a specific amount of time for a day or whatever it might be. And so there's never been a direct feedback loop between a monitoring system that monitors indoor air quality pollution, things like humidity, chemicals within the air, or even particles like PM 2.5. And what we've done is essentially created a system that monitors those and then also links up to your existing ventilation devices to get rid of those in a proper amount of time and using the proper equipment that you have.
Okay. What is contributing to, I don't know, carbon dioxide or VOCs or that particulate? What's driving the bad air in the house that you're trying to solve for?
Yeah, there's kind of two things that kind of drive to that pollution that I talked about earlier. The main thing is really just our everyday lives. The things that we do within our lives, whether you know it or not, generate pollution within your home. If you're cooking, you're generating PM 2.5. You're taking a shower, you generate humidity. You just sit there and breathe, or you have a party where you invite a lot of people over, you're generating a lot of CO2. And oftentimes we don't even realize that a lot of these pollutants are kind of reaching unhealthy levels, and we don't even know when to use our ventilation products for and for how long. So the kind of first part of that is just us living our normal lives. And the second part of it is as homes become kind of more and more energy efficient, they've really kind of closed off any of the natural ventilation, the holes in your home, we'll call them, where air could naturally escape and naturally infiltrate your home. And that's a great thing for energy efficiency. That means your energy bills are lower. That means you don't have to heat or cool for as long. But the downside of that is essentially you've created a bubble where you live in, where all of that pollution that I talked about earlier has a hard time escaping. And so you need to rely more and more on mechanical ventilation. And what our system does is it takes that ambiguity out of the question, where our monitors both monitor and then also take care of the problem for you automatically.
Okay. So Brian, you work directly with clients, builders, architects, et cetera. Are these folks aware of the problems that Taz is identifying, or how much work do you have to do to help them understand the problems before you solve the design system?
I think it really runs the gamut, depending on the region, the municipality, the builder, the architect, the client. Everyone's on their own learning curve. All this is new in the last decade or two, right? In terms of changing how we ventilate homes in the last, 10 years. So whether they're asking about a particular product or how to meet a code, that's kind of where it comes to. They see the code and they say, I know I need to meet this, I just don't know how to do it, right? And so that's kind of where Taz or I might come in and say, well, here's some products that we should consider. Which one makes sense for you? Is this a retrofit installation? Is it new construction? What are the constraints, right? And then we kind of attack it from that point of view.
So for builders and folks that are working with homeowners, is there a need for a lot of education about what's creating the air problems in the house, whether it's pet dander or what you do for cooking or other things that you do in the house, cleaning materials? How do people become aware of the issues?
Yeah, I think there is some education. Taz threw out PM 2.5. A lot of people outside of the industry might not know what that means, but it's basically very small particulates in your home that measure less than 2.5 microns, right? So this is tiny stuff that can get into your lungs and get down deep into the tissue and never come out. And this is a problem for our bodies to deal with this on a regular basis, And earlier in the talk here, we talked about water quality, right? We might take in 1, even 2 gallons of water during a 24-hour period, but we according to the American Lung Association, we take in about 2,000 gallons of air every day. So
Oh, wow.
air quality is much more important in terms of what's in that air, right?
Sure.
Or talking about chemicals, building scientists refer to it as total volatile organic compounds, or TVOCs. So those are chemicals that are off-gassing from both the products that we bring into our home, but also the building materials we use to construct our homes. So all of this is part of the education that's required for the builder, for the client, and then we can go and try and mitigate these issues, through these systems.
Sure. So I assume that you might get a requirement that says, just help me meet code. I'm building a new house. It's X number of thousands of square feet. It's going to be really airtight. And then you might have other people that come in and say, I have children with asthma, and so I need a little more protection. What are the ranges of like a good, better, best option that you can deliver based on the requirements?
Right. So when the IECC, the International Energy Conservation Code, came out in 2012, that was the first time I'd seen whole home mechanical ventilation system required. And so that was a big thing. What does this mean? How do we address this, right? But after that, you can say, well, what kind of filtration do we want on that? What kind of MERV rating, what kind of filter do we want taking particulates out of the air? And can we do that without bringing in more fresh air than we need, right? Again, we're going to get to a feedback loop idea, which is part of bigger, commercial buildings with building automation systems, but we still want that benefit, even if we don't want the whole building automation system, right? So knowing how much chemicals are in the air, knowing how much particulates can be pulled out through a filtration system, well, a fan has to run to do that. So where are we going to get the fan into the system?
Is monitoring a big part of your systems, or what types of monitoring systems are available?
Monitoring for residential projects is very new, right? It's so nice to have a feedback loop, but until now, we really haven't had it. I'll give you the example of a thermostat. If you use your thermostat to heat your home, the thermostat should know what temperature the home is and what you want it to be. We've never had that on the ventilation side in residential construction. It's always been code driven. Number of bedrooms or number of people. Back in 2009, the first time the code said we needed fresh air, it was 15 cubic feet per minute per person. And that was it. Was it enough? Was it not? We're not sure, but it was someplace to start. But that was 10 years ago, 12 years ago now. So it's good to see that the systems and the controls are starting to catch up with what the clients are asking for.
I'm sure like there are systems for clean rooms and commercial applications, and they're just probably not cost effective for residential, or haven't been.
Right. A lot of people will come with a preconceived notion that they need a HEPA filter, and that's not necessarily true, right? If you have asthma or there's other underlying conditions, health issues that need to be dealt with, that's a different situation. But a standard issue, MERV 12, MERV 13 filter is plenty fine, which is multiple steps down from HEPA. But we ask questions, like, do you have respiratory issues, or do you have pets in the home? Pets put out, 2 to 2.5 times the amount of carbon dioxide that a human does per pound. So these are issues that need to be dealt with and questions that should be asked.
Taz, tell us a little bit about the new Overture product and solution, and how does it work? How does it integrate with the ventilation equipment, and what is it doing to help keep the air clean?
Yeah, absolutely. So like Brian mentioned, if you take the thermostat example, it's almost as if we've developed kind of the sensing technology that goes into your thermostat, but for your air quality, right? So we've got sensors within your home, within our products that you can plug in either from a retrofit perspective or a new construction perspective that monitor kind of 4 main pollutants within your home: humidity, PM 2.5, TVOCs, and CO2. And at any point in time, we've set individual thresholds for those items. If they go over what we would call our poor air or our above level thresholds that we've set up, it'll automatically turn on your ventilation devices accordingly. So to give you an example, if you're cooking, right, and you're emitting a lot of CO2, you're emitting a lot of PM 2.5 in the air, it'll automatically turn on your range hood until that pollutant is taken care of. One of the examples, or one of the things that they always say is you should always turn on your bath fan for an extra 20 minutes after your shower. Well, that could be a good guideline, but that's kind of exactly what it is. It's really a guideline, right? It really depends on a number of different factors: the humidity level within your bathroom, the size of your bathroom, how long you took your shower for, and a lot of these things, again, we can't sense individually, so we're not good at. I couldn't tell you if the room that I'm sitting in right here is 50 or 40 or 60% humidity. So we really needed a very accurate system to identify where these pollutants are within our homes, and then which device to turn on and, to essentially take care of that. So we'll turn on your bath fan for, you know, however long it needs to be on to take care of the humidity in your bathroom. We'll turn on your range hood to take care of the pollutants in your kitchen. And then we also connect to a number of our fresh air products. So our ERVs, HRVs, that can be connected to Overture to not only exhaust the air, but also bring in fresh air from outside and filter it through our products. So it's a two-step product, or a two-step process. Essentially, we ventilate out or exhaust out a lot of the pollutants, as well as dilute that air by bringing in fresh air through our fresh air products.
Excellent. Brian, what type of homes are you servicing? Is this just for custom high-end homes, or do you know, where's the home type level?
Yeah, all homes need ventilation at this point, right? Like Taz was saying, the codes have required that homes get tighter and tighter, and so that just makes indoor air quality lower and lower, right? I like to say that comfort and energy efficiency are opposite ends of the same spectrum, right? As you get more efficient, comfort becomes harder to hit. It's really important to address energy efficiency as well as comfort at the same time. And so, you know, back 10 years ago when mechanical ventilation was first introduced to homes, people just install an exhaust fan in the bathroom and just let it run continuously. And that's better than nothing, but we had these leakier homes 10 years ago. And so those bath fans would do an okay job of bringing in new air and diluting that CO2 in the home. You know, but that's not necessarily the optimal way to ventilate a custom home, right? That client might want a little more control over what's going on in the home. And so having a fresh air system that delivers fresh air and not only exhaust is more important. So having a balanced system now has become kind of the go-to for custom homes with our custom home builders.
Got it. And Taz, with the Overture product, where are you targeting that? Who are you targeting that towards?
Yeah, I mean, it really fits in any scenario. So take it from a kind of retrofit perspective. Our products work as a plug and play approach, where we essentially have our room sensors that connect directly to a 120 volt outlet. So there's no wiring or anything needed from that perspective. We have our wall control that also connects to your bath fan or your range hood. And that's as simple as wiring a light switch or a switch for your bath fan. And then we have our smart plug that connects to, again, either your supply fans or your fresher systems like your ERVs and HRVs. So those three products can really work in any scenario. It can target, again, retrofit, all the way up to high-end custom homes where this product can really, again, with the correct ventilation products, really shine and really take care of indoor air quality with your hands completely off the system.
Sure. And Brian, so retrofit, I don't have an ERV or an HRV system in my house. If I was going to want to increase or improve my indoor air quality, I've got maybe a filter on my central air. I do have hot air, forced hot air. What are the options that you have in retrofit to add some of these ventilation products?
Yeah, so we keep talking about ERVs. These are energy recovery ventilators.
Thank you.
These are two fans, one exhausting the stale air from the home, and another fan in the same location, in the same appliance, bringing fresh air into the home. And this is kind of our go-to because it's the safest way to do it from a building science perspective, and not pressurizing or depressurizing the home, providing balance. What comes in must go out of the home, and we want to know how we're doing that and controlling that. So this is typically an appliance that would go, near your furnace and possibly exhaust, some area that needs it. Might be a bathroom, might be a living space, right? But this is a great retrofit or new construction idea to be able to add this fresh air to the HVAC system and then distribute it through the home, through that existing ductwork or through the planned ductwork, right? So we don't need to go and engineer a bunch of additional ductwork that needs to go into the home.
So Brian, if a builder is, I'm assuming they obviously know they need to meet code, that they're not going to get an occupancy permit without it. But if they're looking to step up and in addition to meet code, offer, a marketable benefit of better indoor air ventilation, what are the things that they should look for or do first to get started?
Well, I think the first key might be that if their clients are asking for it, right? Then you know that there's a market out there. And so once you put it in the home, you can start talking to that market. You can market the fact that the home is healthier because it might have a MERV 13 filter in the HRV or the ERV, right? So making sure you get mileage out of that install. Not all homes have ERVs, so if yours does, you should make sure you mention it. And so that's kind of the first thing. The other thing is to give education to that potential buyer or homeowner about how it can be controlled. Like, what are the benefits of it? Not just that it's there and provides energy efficiency benefits because it's recovering heat or recovering energy for that particular climate, but providing the health benefits. And I think more clients are open to that now, especially now that it's 2021. This past year has really opened, all of our eyes in terms of what respiratory health, how important it can be.
Yeah, so you think if builders, let's take production builders, if they put an anchor or a stake in the ground with an indoor air quality position, you expect the potential buyers will receive that well. It'll be a differentiation.
Absolutely.
Okay. All right. And Taz, from your point of view, how can builders get involved in indoor air monitoring? Is it a way to get started with a standard and expand on it, or is it an all or nothing proposition?
No, I mean, it's like any system. I mean, there's parts to it, right? And you can always kind of dip your toe in the water for a little bit and then expand on that. A number of builders that we're looking at right now that we're talking to have really used that indoor air quality stand as a way to differentiate themselves, right? So instead of you going to builder Y, come to me because I build my home with low formaldehyde, equipment and materials. I have the proper ventilation, like Brian mentioned. I developed this with an ERV. And the next step up from that is really to go for a monitoring solution, right? We talked about having all of these ventilation products within your home and making sure that they're sized correctly and correct for the customer. And then the kind of level up would be to go to a monitoring solution. And there's a couple of monitoring solutions out there right now. A lot of them do just that. They just monitor the indoor air quality within your home. But where ours kind of takes it to the next level is we connect it to the ventilation devices within your home. So you can start off with a room sensor just to kind of educate the customer about what indoor air quality is, explaining to them what PM 2.5 is or TVOCs are. And if they find that they really want a home, right, with proper air quality and with automated air quality, you can take that to the next step by connecting their ventilation devices as well. So you can get in kind of from a one product perspective, or you can fit the whole home if you'd like.
We're in sort of order of preference. You don't have to go through every home in the house, but where would you start? Where would you put the first sensor to give someone a sense of how their air is doing?
Yeah, absolutely. Number one most polluted place within our home is our kitchen. We don't realize the amount of things that we do within our kitchen that generate air pollution, whether it's, wiping countertops with chemicals, cooking, breathing. We host a lot of social events in our kitchen. They've kind of become the center of our homes, really. And they're not tucked away in a corner like in the past. And so you go into a really nice house, if it has a really nice kitchen, it's a really nice home. So identifying kind of where to put it within your kitchen, maybe next to your stove, maybe next to a countertop of some sorts, but I would start there and then kind of grow out.
All right. Awesome. Hey, Taz, Brian, this has been great. Very informative. I've learned a ton today. Brian, if anybody who sees this wanted to reach you and your business, where should they go?
You can reach me at Rayski at oneworldconsulting.biz.
And Taz, how about you? How can they find out more about Broan and Overture?
Yeah, absolutely. We have our Broan-NuTone.com landing site that they can go to check not just up on Overture, but all of our other ventilation products.
Thanks again to our guests, Brian and Taz. If you want to learn more about Healthy Home, we have 2 events coming up. First, on June 24th, the Healthy Home Alliance will be holding the Healthy Home 101 virtual event, 1 to 5 p.m. Pacific. You can check them out at yourhealthyhome.com. Then on August 17th and 19th, we will have the Tech Home Builder Summit live and in person in Louisville. You can apply to be hosted, meaning we will cover your flights, your stay at the hotel, and all meals during the event. Go to techhomebuildersummit.com. Joe Lautner, Tech Home Builder Webinars, thanks for joining us today.